Hello everyone, welcome you all to this video. So here we are going to solve this question today. So let us read and understand the question properly. Then we will be approaching towards the solution. Okay. So let us read. So here it is saying that it is desired to compress 20 kg of gas from 2.5 meter cube to 0.5 meter cube at constant pressure of 20 bar. Okay, so from this sentence, this is giving some data, right? So we are doing a compression process of certain amount of mass. So mass is given, that is 20 kg, and for a particular gas. So that means here we have to know that this is not the case of your air. That means whatever data we have remembered, that is related to your cp and r. So for air, that cannot be used over here, right? Because it is specifying for a particular gas, right? Okay. So and the initial volume is something which is given to us, and the final volume is something after the compression, obviously. So that is also given to us, right? And the compression is happening at a constant pressure, and that pressure is also given to us, right? Okay. So I hope there will be no doubt to this one. Let us move further. During this compression process, the temperature rises from 20 degrees centigrade to 140 degrees centigrade. Right? So during this particular compression process, temperature obviously will change. Okay, and because pressure is remaining constant, that is why temperature has to be changed, and the initial temperature is given, final temperature is also given, right? And increase in internal energy is this much. Okay, so as the temperature is changing, that means there will be also change in the internal energy, and that internal energy change, and that is the increase in internal energy, that is given to us as this much value, that is 3500 kilojoule. Okay, so what we need to find out, we need to find out the work done, heat interaction, and the change in enthalpy during this particular process. So we need to find out these three data. Again, we have to find out the average value of specific heat at constant pressure. That means again we have to also find out the CP value, right? So average value of your CP, that is specific heat at constant pressure, that we have to find. Okay. So let me write what are the given data to us. So we have to write here given data. So what are the given data? So let me increase the s to certain amount. Okay. So what are the given data? Here mass is given to us as 20 kg. So m we can write this is 20 kg. Okay. Initial volume of the gas, that means V1 is given to us as 2.5 meter cube. Final volume, that is V2, is given to us as 0.5 meter cube. Okay, and this is happening during a constant pressure process. That means we can write down this is P1 will be also equal to P2, that is given to us as 20 bar, right? So initial and final pressure is same, that is 20 bar. Okay, and during this compression process, the temperature rises. That means temperature initially T1, and it was 20 degrees centigrade. So if we want to write in terms of Kelvin, then we can write down this is as 293 Kelvin. That is 20 plus 273. So that will be giving us the 293 Kelvin, right? Okay. And the final temperature is also given. So T2 is equal to 140 degrees centigrade. Okay. And that will be equal to 140 plus 273. So that will be giving us the 413 Kelvin. That is 413. Okay. Other than this, the change in internal energy, that is also increasing. Here you can see there is increase in internal energy. That means you can say this is del U value, and that is equal to U2 minus U1. That is equal to 350 kilo. Okay. So these are the given data for us. And what we have to find out the work done heat interaction, right? So what is the work done? So you can write down over here to find what is what we need to find out. We have to find out the work interaction from one to two process. Okay, then we have to find out the heat interaction Q1 to 2. Okay, then change in enthalpy. That means we can write del H. So this is how much. Other than this, again we have to find out the value of Cp. So we have to calculate all these four values, right? Okay. So obviously you can understand this is a question from the first law of thermodynamics when it is being applied to a flow system. That means there is a particular container, right? Okay, and during that container we can say this is a kind of your piston cylinder arrangement where some certain amount of mass is fixed inside that container or inside that cylinder arrangement, we can say. And what we are doing, we are trying to compress, right? That means we are pushing the piston towards the inner dead center, right? So during this process what will be happening, the volume obviously it is increasing, sorry, decreasing, and but temperature is also increasing. Okay, so volume is decreasing, temperature is increasing, and pressure is remaining constant. That means if we'll be trying to plot this process on a pressure versus volume diagram, then definitely we will be getting a horizontal line, right? Okay, so I'm not drawing that. Okay, let us, so that we can understand this question in a proper manner. Okay, so we will be drawing the pressure versus volume diagram. Okay, let me take the pressure in um, y-axis and the volume in x-axis. So definitely our curve will be somewhat like this. That is the horizontal line, you can say, right? So there will be a horizontal line. So this horizontal line will be showing us um, the process, right? So here I am taking P and here I am taking V.